let's dive into an application of some of these radical equations or inequalities. We start off with two cars start moving from the same point. First car traveling north at 10 a.m. at a rate of 60 miles per hour. Second car traveling east at 11 a.m. at a rate of 75 miles per hour. And they want to know how far apart are the cars at 1 p.m. So before I even get intimidated about an equation that I have to come up with, I really need to draw a picture of the situation so I know what I'm supposed to be doing. So we start off with two cars starting from the same point. So here's my same point. And then I just have to understand the north direction. One car is traveling north at 10 a.m. So north would be straight up. That's north. At a rate of 60 miles per hour. I'll kind of help me with that. So I have 60 miles per hour, just in case I need to use that information later. The second car started traveling east at 11 a.m. So east would be to the left at a rate of 75 miles per hour. So I'll draw that information just in case. And so what they want to do is they want to figure out how far apart are the cars at 1 p.m. So if the cars are strictly traveling on the same path, so there's no curving happening, each car will have a set value exactly at 1 p.m. So if you were in the sky in a plane and you took a picture of both of the cars exactly at 1 p.m., you would see their positions. And when they want to know how far apart they are, they're actually just asking for what is the length of this line that separates them. Now I'm hoping you see it, but if not, I'll give you a hint. When you had the setup of the directions, one went north, one went east, and no one took a different path along the way, I'm hoping that you're able to see that you have yourself a right triangle. And that makes me happy, because if I have a right triangle, I gotta know how to spell triangle. There we go. I have a theorem that relates all the three sides of the triangle. And it's a famous theorem. I don't know if you remember Pythagorean theorem. And what the Pythagorean theorem says for us is it tells us that let me see if we talk about this. If I were to label this, I'll say A, B, and C. The sum of the squares, so the squares of the legs, A square plus B square, equals the square of the hypotenuse. In that case, it's C square. So I want you to recognize the hypotenuse is always directly across from the right angle. So now we're getting somewhere. What we need to understand though is, do we have numbers for any of these A, B's, or C's? And we actually do, it's just not given to us straightforward. They do want us to figure out what the distance is between the two cars, so I know for sure that that is C. So I know I don't have a number quite there yet. But I can use the concept of the fact that they're telling me that I'm traveling 60 miles per hour and 75 miles per hour. I'm assuming uniform speed for this type of word problem. I'm gonna look at how many hours have we all been on the road. So the first car who's traveling north, right? So first car, just kind of notes to myself. If they start at 10 a.m., and we're taking a picture of them at 1 p.m., how many hours is that? So I just have to count on my fingers usually. So 11 a.m., 12 p.m., 1 p.m., that's going to be 3 hours on the road. So if I know that I'm going 60 miles per hour and there's 3 hours on the road, what do we have? 60 plus 60 plus 60, or 60 times 3 miles, which is what is that? 60 times 3, 180 miles that the car has traveled. So right away, I can replace A with 180 miles. And I'll do the same thing for the second car. So the second car, you just kind of have to think through times. It actually started at 11 a.m. and we're taking a picture at 1 p.m. So if I kind of count, 11 a.m. Okay, so that means 12 p.m. and 1 p.m. That is 2 hours on the road. So if that's 2 hours on the road and that car was traveling at a rate of 75 miles per hour, I actually have 75 miles for the first hour, 75 miles for the second hour, which is 75 times 2. I'll write that a little nicer for you. So that gives me 75 times 2, which is 150 miles that the car has traveled. So instead of B, I know that that's 150. So that's kind of a nice way. We see these types of problems kind of show up again in trig class, pre-calculus, sometimes calculus. That's helpful for us to interpret it with times and how long we've been on the road. So after we come to this conclusion, I basically have myself a new right triangle, and I'd like to draw it for you just because I have nice fancy graph paper. We do not know who C is, but we do know that the length of one of the leg is 180 miles and the length of the other leg is 150 miles. And we can utilize our Pythagorean theorem. So now we can go with the fact that we have 180 squared plus 150 squared equals our hypotenuse squared, our C squared. That's the distance they are apart. If you wanted to name it D for distance, that would have been a better move. Hindsight, oh well. Well, now it's not too crazy of an equation to deal with. We have to just kind of use our calculator and we say, okay, what's 180 squared? So I'll type that in off to the side. And I know that that's, at this point, it's 32. I have 32,400. And 150 squared, if I'm calculating that, I have 22,500. Still equals C squared. We'll add these two. Just being real careful. So I do have 54,900 equals C squared. And now if you remember, I know it doesn't look like a radical equation, but in order for us to find C, we have to undo the square, so we work backwards, taking the square root of both sides. So what we end up having, C, the distance. And now it is true, if you take the square root of both sides, you do have a plus or minus, but we don't include the minus sign because there's no way you could have a negative number of miles. So this is why we're taking only the positive case. So now if we're looking at square root of 54,900, I probably use my calculator to see if this ends up being a nice number, 54,900. And no, it's not really a nice number, but I'll give you the approximation. So I have something like 234.3075 about. I'll even draw a little approximation symbol for you. But if we were looking at this, we're trying to say, what are we trying to answer? We state, what is the answer to our word problem? How far apart are the cars at 1 p.m.? I probably restate this in English. Therefore, the cars are about 234.3 miles apart at 1 p.m. And again, remember, if you can restate your conclusion to the mathematics in English, this is where you make the big bucks.